Thank you.
Good morning. And thank you for the opportunity to present here today. About myself a bit, I'm Braun. I'm the Chief Product Officer of ELTA Cyber Division, and in addition to that, I'm the CTO of CyITS, and I have some other activities as well. More than 20 years in the cybersecurity industry in multiple positions, most of them in technical capacity. Disclaimer, I'm not going to go through it. You can read it. It's important. I'll try not to do any mistakes in what I'm saying regarding that. About CyITS, let me cover that, so I'll skip it. My presentation is a bit more technical, so bear with me. I'll try to keep it not so much technical. Start with the motivation of the attackers, because I think it's important to understand, it's very important to understand where we're going to. And if we look at the broader point of view, attackers today have two main purposes. First one is profit, and the second one is to create some impact. I'm not going to dive into that too much, but just to give you an idea that the cybercrime economy is the third economy around the world today. And the main area for the criminals or the bad guys is to get some profit from the cyber attacks, and they're looking all the time for ways to monetize cyber incidents, and this is one of the main challenges we have to face. If we dive into the automotive industry, the main challenges or main motivations for the threat actors is first of all to gain control of critical vehicle capabilities, the steering, the brakes, the acceleration, and so on, and to compromise the safety of the vehicle. Secondly, to disturb the vehicle operation. It can be either simple single vehicle, which is quite simple, or it can be to do it in a more larger perspective to disrupt the operation of a city or a large road or things like that. And we can see that in some places around the world that it can be part of more advanced or more complicated scenarios in which we are manipulating vehicles in order to, or transportation systems in order to get a potential impact in other areas. We can do physical harm or financial losses by crashing vehicles, by stopping activities, operational systems, and so on. We can deal, or attackers can deal a lot with privacy of the vehicle passengers. It can be either by collecting information about the vehicle movement, and by that location of the person. It can be in some places getting information from the vehicle and behavior of the driver. And one thing that we can demonstrate today, we can show how we can record the vehicle, inside the vehicle, discussions or anything that is happening inside the vehicle remotely quite easily. And this is a threat that's available today in most of the modern vehicles. And of course, attackers are looking for intellectual property. And one of the interesting things that become more popular in the recent 2 years is activating locked features. Porsche and Mercedes presented to the market vehicles with some features which are locked behind the payment method, and the attackers managed to break those barriers quite easily. And because of that, Porsche at least stopped distribute one of the vehicles, because all their business model for that vehicle is in collapse quite fast. So we have to take that into consideration. Modern vehicle become very complicated. In the past, we have engine, steering, brakes, and so on. Today, the vehicle is a computer on wheels with a lot of systems that automate activities in the vehicle, that connects the vehicle to the external world. And those automations have very interesting capabilities. It's improved the comfort and the capabilities of the vehicle. In some cases, it's improved the safety of the vehicle, but eventually it exposed the vehicle to multiple potential attacks. It increased the attack vector of the vehicle, and the vehicle become more vulnerable to potential cyber attack and to external attempts to attack the vehicle. So the vehicle becomes a very complex system which consists of multiple systems, multiple devices. Some of them are computerized devices, and all of them are coming from multiple vendors that need to operate together. And as a car manufacturer, they will choose eventually the most cheapest device they can use. So the vehicle is comprised of more than 100 different controllers and systems. All of them are coming from the cheapest provider they can afford at this specific time, and we have to take that in consideration. Actually, if you're looking at the composition of a vehicle today or during the years, we can see that the part of the electronics and computers in the cost of the overall vehicle is growing rapidly in the last few years, from 80% in 20,000 to almost 50% in 2030. So the part of the electronics and computer systems in the vehicle is growing continuously during the years. The main concerns that we have to take in consideration is, first of all, the safety of the vehicle. And with all those computerized systems, we have to make sure that the safety of the vehicle will not be compromised. Secondly, the availability. It is quite easy to disable a vehicle remotely today. Comfort of the passage and the privacy of the passage, all of them are areas that we have to take in consideration when I deal with security for vehicles. We are talking a lot about autonomous vehicles, but just to make it clear, there are 5 levels of autonomous vehicles. Today in the mass market, we are only here, only in the beginning of the automation. But even with that, when you're talking about modern vehicle today, we added a lot of capabilities that aim to increase the safety of the passage. And by that, we are actually taking set of sensors, connect them to some kind of processing and fusion center, and then connect them to the main systems, safety systems of the vehicle, the braking, the acceleration, the steering, and some driver alerts. All those capabilities are actually exposed the most sensitive systems of the vehicle to an outside intervention. And the vehicle attack surface is growing because we want to increase the connectivity of the vehicle with multiple technologies. We are coming to the vehicle. The first thing when we are entering to the vehicle, the first thing we are doing is we are connecting our phone to the Bluetooth or to USB. So we are actually connecting the vehicle to the internet. If we look at the previous slide, we are connected the systems of the vehicle to the most sensitive safety systems. We connected the vehicle to the internet, and this is the potential implication. The most sensitive system of the vehicle are exposed to the internet. And if we take an example to demonstrate that in more details, all the vehicle systems are connected in several networks inside the vehicles. Most of those networks are relying on a CAN bus protocol or some other protocols. All of them are connected through a single gateway that operates like some kind of a firewall inside the vehicle. All those systems are connected to the infotainment system of the vehicle, which is a common infotainment system. This infotainment system is based in most of the vehicles today on some kind of variant of an Android or a Linux systems. This system has vulnerabilities. Those systems can be attacked, can be compromised. And I'm not going to go through all this process of patching the vehicle and compromising the infotainment system, but we can demonstrate that in our lab, how easy it is to compromise the infotainment system through that system to get access to the entire CAN bus network of the vehicle, which means to get access to the steering, to the brakes, to the acceleration of the vehicle. And we can do that remotely. How the attackers are getting that information, and it is not so complicated to get that information. They can go to a junkyard of vehicle after an accident, grab the parts that they want to analyze, bring them to the lab, break the data vehicle, and analyze it. Most of the information that they need is available in open source. In order to provide capability for everyone to fix his own vehicle according to at least European regulation. All the information, the technical information about the vehicle and how systems are connected, how the composition of the vehicle and so on is available online. You can access it. It will cost you about $20 per day to get access to that system. All the information is available. We at CyITS did it. We took a vehicle after a total loss accident. We decompose it from the mechanics parts and build it in our lab. The bad guys are doing the same. They are using the same methodologies, the same tools in order to get a knowledge about the vehicle, about the components of the vehicle, to do reverse engineering of systems, and to know to get information about what they need to do. This is the process that the attackers are using today in order to get information about the system. They can get a lot of information from different components that can get in the open market quite easily. Some of them need some technical capabilities. Some of the data that can be extracted can be extracted quite easily. And the risk with that is that we can get different software variations. Based on that, we can get a lot of information about vulnerabilities of the vehicles. We can get a lot of information about JTAG and UART password, which are the password to get into the firmware of the vehicle. We can get a diagnostic password and many other technical parameters that can allow attackers to learn everything they need in order to compromise different components of the vehicle. And this is something which is quite easy to do. And we know that attackers around the world are doing that. We have knowledge about it. We can see that in different forums. This information is available in the market, and we have to be aware of that. So if we think that it is a close behind some box and some password, forget it. The information about any vulnerabilities around in our vehicles is available in the market today. And the risk is that attackers can identify and map attack vectors of systems of vehicles. They can extract IP, intellectual property, and unique capabilities of different vehicles. They can manipulate off-the-air updates. And they can create malicious deployments. So get inside the process of off-the-air update or garage update and install in the vehicle manipulated firmware. This is something that can be done, and it is done already. It's already done. We can build backdoors in the vehicles, and we can build the processes in order for further attacks. It is less critical for single person and its own vehicle. It is more critical for more sensitive vehicles, for public transportation systems, and for more advanced attack scenarios in which attackers will try to manipulate large amount of vehicles in order to create impact and not just to play with specific vehicle. The scenario that someone will take control of your vehicle and ask you for ransomware while you are driving is less probable, because even attackers are smart enough to understand that when you are driving and you lost your brakes, you will not be able to start to buy Bitcoin and convert or then send them to some potential address. So this is not the more probable scenario, but there are other scenarios which can be more probable. The risk for the vehicle is not just as part of the design process. The life cycle of a vehicle includes the design phase, the manufacturing, the dealership, what the activities that will be done in the dealership at the local countries. After that, in the customer or owner activities, and then during the maintenance time. For each phase of that, there are the risks that involve the dealing with the vehicle. For each step in this life cycle of a vehicle, there are unique threats and unique challenges, and we have to be aware of them and to be able to address them. And there are many standards that are aimed to support those challenges and those threats. And it is important here to distinguish between standards and regulation. Standards are more technical and very detailed. but they are voluntarily be deployed. Regulations are the tools for governments or for institutions to enforce the use of standards. And today we are mixing between the two of them, and that is a challenge that we have to address. In addition to that, if we talked earlier about the maritime lack of regulation and standards, in the automotive industry we have plenty of standards, plenty of regulations spread all over the world, and the main challenge is to understand which standards and which regulations are more relevant for us, which standards and regulations we have to follow in which country. Today there is regulation for the European market, it's not relevant for the US market. There is standard for the European market which is not relevant for the Chinese market, and so on. But most of the cars today are coming from those areas and not from Europe. So it is a challenge that the industry didn't solve yet. And the main challenge yet is that when you have so many standards that competing each other, someone will come to say, I will bring the new standard that will cover all, and after some time, we have 15 standards that are competing with each other, and this is the reality today in the automotive industry. And the challenge with all those standards today is that most of the standards define what we need to do, but they don't define anything about how to validate and how to check that the standards was addressed correctly. There is no standard on how to test the resiliency of vehicle against cyber threats, and this lack of validation processes make the standards a bit complicated to follow and to use effectively. Having said that, there are three areas that need to be that I recommend to look for, because they aim to solve some of the challenges. First of all, ISO 8475 aim to define the methodology how to test a vehicle against cyber threats. It aims to solve one of the main challenges of the existing standards. This standard is in process. I don't know how much it will take to facilitate standards. Once it will be facilitated, it can be a very interesting breakthrough in the way we are testing vehicles. But from the other end, the ISO 8477 is more or less in the same area. Those two standards are competing each other in many areas. Which standard will take place and which standard will be more effective, we don't know yet. In addition to that, there is a process to harmonize the two competing standards. One of them is the ISO 26 whatever, which is mainly focused on safety, and the ISO 21444, which is mainly on cybersecurity. Those two standards are competing each other. In some areas, they are saying totally opposite things, and there is some process now to harmonize those standards together. This is a critical issue, and it is in process. It will take some time. Eventually, they will succeed to do it. Let's put aside the standards and go back to the reality, what we really need to do in order to address the threats that we have. So first of all, we need to build a process that will start from the TARA, from the threat modeling of a vehicle, of a system, and will take us up to the tests of the vehicle. We need to build the attack tree. What are the potential attack scenarios that we need to take in consideration? To design a system to address those attack scenarios, to make sure that the implementation is according to the design, and then to build the test scenarios to make sure that we are testing the vehicle or the system according to the attack tree that we built in the beginning. And in order to do that, there are multiple ways to do it. I think the MITRE attack model, which was built originally for IT systems, is a very effective starting point. The MITRE attack model was extended a few years ago to deal with OT systems, and just a few months ago, the Auto Isaac, American Auto Isaac consortium distributed an automotive threat modeling matrix, which is based on the MITRE attack model. I think this is a very good starting point to start building the attack scenarios model for testing of vehicles. There are multiple technical features and technical considerations that we can take when we are designing a system, we are testing a vehicle. I'm not going to go through this list because it's too technical for this kind of session, but just to give you an idea, we have to look at the system as with proactive approach for cybersecurity. Of course, secure coding practices along the design and development process. We have to deal with the hardware-based security features like anti-tampering, like secure manufacturing processes, and so on. All the memory management processes and how to make sure that we are dealing with the memory management in the right way, application isolation, and so on. Root of trust inside each CPU, each ECU, each component of the vehicle, and root of trust across the vehicle to make sure that the vehicle is based on single root of trust. This is a challenge that was not addressed yet by any car manufacturing. Secure boot, once again, for each component separately and for the entire vehicle. Trusted security platform, and TPM, and hardware security module, and all the components to maintain password, keys, and so on in the vehicle, and how to manage them remotely, and how to manage them across the updates of the vehicle. This is a challenge that we need to address. All the way we're using cryptographic components in the vehicle, how to manage the keys, how to secure the key length, how to maintain that during diagnostic while the system is in a maintenance phase, and so on. How to secure the off-the-air updates. And there are more and more vehicles who are supporting off-the-air updates, how to make sure that those updates are legitimate and will not compromise during the process. How to secure diagnostic processes in the vehicle. This is a challenge that was not addressed correctly by most of the car manufacturers and OEMs around the world. And we need to add the security across the entire life cycle. As we presented earlier, the entire life cycle, we need to consider security at the dealership, at the garage, when we are bringing the vehicle to maintain it in the garage, how the security will be maintained, and how to secure the supply management, the third parties. When I'm coming to the garage, how to make sure that the product or the device or the component that they are replacing in my vehicle will be a legitimate one and not a device that will be compromised as well. And this is only part of the challenges that we have to deal with them when we are dealing with vehicles. This is not just part of the designer of the car manufacturer. We have to deal with them here, even in our small country, because they are covering the entire life cycle of the vehicle, and we are not dealing with that correctly at this point. We spoke about autonomous vehicles and the autonomous level that we have today. But if we're looking at the future, vehicles will become more and more autonomous, and the level of autonomous capabilities will grow in the near future quite significantly. This level of automation increase the attack vector, increase the challenges that we have to address quite significantly. And when we are talking about autonomous vehicle, we have to take in consideration that we are talking about a bit more complex system. We have, first of all, the base vehicle, the vehicle itself. In some cases, it's a unique vehicle that was designed to be autonomous, but in most cases today, the autonomous vehicles operators are taking a vehicle out of the market, standard vehicle, and add to it an autonomous vehicle system that will automate the operation of the vehicle. So we have to address the security of the base vehicle. We have to address the security of the autonomous vehicle system. And on top of that, we have the command and control system or the management system in which the autonomous vehicle operators will control the fleet of vehicles. Each one of those layers has its own attack vectors, its own vulnerabilities, its own challenges, and only this level, this layer, have some security regulations. Those two areas have no standard, no security regulation. It is only what the operators of the vehicle will provide. The only place around the world today who has some regulation that deal with the security of these layers is here in Israel, and this is what we are doing in CyITS. I want to give you a very simple example about the potential implication of cyber attack against the autonomous vehicles to understand the challenge that we are facing. In most of the modern vehicles today, most of the vehicles today, we have a system that called TPMS. TPMS is a very simple system that aims to monitor the tire pressure across the four wheels we have. This system is a very simple system. It transmits information from the tire to the vehicle in UHF. Very simple UHF communication. With a very simple equipment that we can buy in less than $300, we can intercept that information. And what we can learn from that interception is that the information about the TPMS system is a cyclic transmission. Every few seconds, this information will be sent from each tire to the ECU in the vehicle, to the component in the vehicle that collects that information and calculate the tire pressure of the wheel, of the tires. There is no encryption with that information. There is no authentication. This is a very static ID for each tire. So actually, to manipulate those transmissions is very simple. It costs almost nothing. So if I will put one receiver in one location to collect the ID of the tire and to synchronize the data with the transmission of the vehicle, and I will use a transceiver that will transmit data, fake packets about this data, I can quite easily manipulate the vehicle to think that he has a loss of pressure in one or more tires. And the impact for that is very simple. If I am in my own vehicle and I got the light, the signal of loss of pressure in the tires, I will stop aside and see that nothing has happened. I will get into the car and move away. If it is 100 vehicles in Ayalon highway that got that loss of pressure signal, traffic jam. But what will happen if this is 200 autonomous vehicles in Ayalon that got this signal of loss of pressure? When we discuss that with some of the autonomous vehicles operators and manufacturers, they say, we didn't think about it. And this is a challenge, because in some areas, very simple attack that can be addressed quite easily by local vehicle or by single vehicle with a driver will be major crisis for autonomous vehicles. And autonomous vehicles manufacturers today are dealing mainly with the safety and how to make sure that the vehicle will not run into some other vehicles or people, but not take that in consideration. This is something that critical to be addressed. Just to make sure, this process of TPMS attack was simplified for this presentation. It's a bit more complicated. There are other challenges that can be addressed with that. The fact that we are the vehicle is collecting information with non-secure channel and send it to the internal vehicle, it is a challenge. We can generate more advanced attacks than just the tire pressure management system through that attack vector. And this is something that some of the vehicles are addressing more effectively, some of them less. And it is important to note that there are some compensating features in the vehicle that can be that can be used to address that specific challenge and to solve it. But they have their own vulnerabilities and their own problems as well. these challenges exist significantly. And the conclusion from that, first of all, vehicle cybersecurity is a multidisciplinary challenge, and this challenge has to be addressed in that way. The standardization, the existing standardization of the vehicle cybersecurity is not enough, and it's not effective. And this is something that we need to address. Automotive security has to be addressed in a holistic view, holistic approach, because we cannot look at a single ECU, single component, and address it as a simple single system. The vehicle is a complex system with multiple components. We have to address it as a whole solution, and we have to look at the different layers of the automotive system, especially when toward the autonomous vehicles. We have to address the cybersecurity of the automotive world across the entire life cycle of the vehicle: the design, the manufacturing, the dealership, the user operations, and the maintenance. Otherwise, the breaches will come in the ways we are not expecting them to come, and they will come. And I believe that at some point, the attackers will find a way to monetize attacks against vehicles. So we have to be aware of that, and hopefully we'll do that before each significant incident will arise. As the level of autonomous of the vehicles will increase, the threats will increase as well, and we have to be aware of that. From my point of view, when there is a challenge, there is an opportunity, and this is where we are at CyITS, and we built in CyITS the capabilities, and I dive a bit deeper from what Chemi presented earlier, our unique capabilities in threat modeling, in reverse engineering, in analyzing vehicle vulnerabilities, and defining solutions, and working with the manufacturers and operators to find ways to address the security challenges of the vehicles. This is what we do at CyITS. Questions? Yes, please.
Quick question, just so I understand, before I ask the question, are you a private organization or a public organization?
CyITS is a joint venture of IAI ELTA with the INCD and Ministry of Transportation, but we are a private organization.
So my question is, are you seeing that vehicle manufacturers are beginning to build organizations like yours internally to exactly test the type of things you are? It sounds to me like they're doing their thing, and then you're examining and saying you got a problem here, as opposed to this being part of their overall, I guess, quality control, like they have on engineering. Should they not have a similar type of thing here? Or at least I'm asking, do you see that there?
So first of all, most of the more advanced car manufacturers are building their own internal cybersecurity capabilities, and this is great and it's important. But I think that some of the challenges are beyond the scope of the specific manufacturer. For example, if I'm a manufacturer of a vehicle and my vehicle will be used by some autonomous vehicle operator, and he will add an autonomous vehicle system to the vehicle, it is beyond the scope of me as a car manufacturer. In addition to that, a car manufacturer will test its own system. He has to find the right balance between security and cost, because he wants to make profit. Should be an external entity that will validate that what the car manufacturer are doing is in line with the regulation or the standards that they are claimed to comply with.
That sort of shifts responsibility away from them.
We're not shifting responsibility. This is their responsibility.
Or let's say liability.
This is their liability. They are liable, yes. As I said earlier, I'm not a legal expert, so I'm not going to get into the legal aspects of that, but we're not aimed to replace the responsibility of the car manufacturer with the provide security and safety for their systems. We are just validating that what they claim to say is correct. In the same way that the NICAP test, which validate the resiliency of a vehicle to crash, is not something that they will take the reliability from the vehicle. It's just checking if what the car manufacturer claimed to support is actually meet the reality. Any more questions?
Do you see any
Actually, there are quite significant amount of attacks against vehicles in multiple ways. The first kind of attacks are attacks that aim to steal the vehicle. And we can see huge growth in attacks that use this exact same vulnerabilities in the vehicle to activate the vehicle and to steal it. We saw attacks that claim that try to, first of all the attacks that broke all the model of payment services in the vehicle. Those attacks use the same methodologies. And as I said, attacks that will hold the vehicle and claim for or ask for ransomware unless the driver will pay, unless probable at this point, because no one thinks, even the attackers don't think that when I'm driving, I will be able to pay in Bitcoin something under ransomware. So I think at this point, the attackers are trying to build the ways how to monetize attacks against vehicles. They will find a way. Hopefully, we'll find a solution before they will find a way to do it. Yes, please.
Is anyone in Israel, CyITS or any other body, ready for an attack similar to the dealerships attacks in the United States last week?
We are not dealing with dealerships. Any more questions? Thank you all.